to Rupa's online tutorials. In today's video, I'm going to discuss the basics of Python, that is keywords, variables, and the different data types Python supports. So let us look at this, what we will learn today. So I'll be defining what as keywords, identifiers, variables, comments, and the data types which make up the syntax of the Python program. Understanding these concepts clearly is very important to write efficient and good programs that solves the problems. Now let us look at the first word, keywords. These are also known as tokens in other languages. That is the smallest individual unit of a program which helps you to write programs in that particular language. So coming back here, keywords are nothing but reserved words. Reserved words means what? Reserved words means these words have some special meaning to the Python interpreter. So based on that particular meaning, the Python will take this particular keyword. For example, we have a class here. It will take this particular keyword and it is going to perform an action based on that. Whenever we talk about keywords, we have to know that keywords are generally written in the lower case only. Okay, they are written in lower case, and there are a set of keywords which I have displayed here. This is according to the 2021 manual. There might be few more keywords which you need to check it out. And keywords cannot be used as identifiers. I'll be telling you what identifiers are in the next slide. So we have to remember that we cannot use keywords as identifiers. Identifiers in Python are the names used to identify the variables, functions, classes, modules, or other objects in your code. Just like you have an identity card, like maybe your driving license or your Aadhaar card or your voter's ID card, which tells about you. Okay, it gives details about you. In Python also, we use some names. But what are these names actually about? These names are used to identify the variables. That means for the variable name, the function name, okay, the class name, all these names, whatever we are going to give in our program or write in our program, those names are known as identifiers. So these names are created by the programmer for writing the programs. Thus, identifiers are user defined. So while you are declaring these identifiers, while you are declaring a function name or a variable name or an object name, you have to follow certain rules, okay, which is being given by the Python interpreter, by the Python language. So here, what are the rules? The first rule is it should start with a letter or underscore. For example, I want to store the marks of the student. Then I can give a name like this. I can write marks like this. Okay. But here identifiers can start with a letter, that is A to Z, capital A to Z, or an underscore. I can also give it like this. This is also a valid identifier. But they cannot start with a digit. So I cannot write like this, 1 mark. This is wrong way of writing the identifiers. So we need to follow these rules while writing these variable names, declaring the variable names or the function names. Many students who are learning newly, or many people who are learning newly, they have to follow these rules so that they do not get any syntax errors in their programs. The case sensitivity. Python is case sensitive. So case sensitive means it differentiates between upper and lower case. Uppercase means capital ABCD, all the capital letters, and lowercase is the small alphabets. Okay. Reserved words cannot be used as identifiers. So reserved words or the keywords, okay, they cannot be used as identifiers. I told you in the previous slide when I told about keywords itself. No special characters cannot be used. Again, when I'm having, like, for example, marks, average, I cannot put a hyphen here. Okay, this is wrong. But whereas I can put an underscore, average underscore marks, I can separate it with a underscore. Or I cannot use, a dollar symbol or a hash symbol in my identifier. Then there are some special conventions. Conventions is just for convenience. We use some conventions. Use lowercase letters for variable names and underscore to separate words in multi-word identifier. That I have shown you here. And for constants, use uppercase letters with underscore. So for example, here pi is equal to 3.14. We know the value of pi is not going to change. So we have represented a constant with a capital letter. So when you are writing the program, it becomes easier for the other users to know that, okay, this is a constant. This particular value is a constant. It is not going to change throughout the program. Next, we talk about variables. Variables are very important because they are going to store values in it, isn't it? So it is going to store values. So variables are used to store data, values, or objects. So every data that we are going to operate in our programs, we need a place to store, and that place, okay, that location is known as a variable. So if you see the definition here, variables are symbolic names that refer to specific memory locations where the data is stored. So what exactly is a variable? It is a memory location. All of us know that our computer is having memory. So this memory, we can imagine it is broken down into cells like this. It's made up of cells, and each of this is going to store some data for us. Okay, so this particular data location is known as the variable. So for example, here I give num. That means in this particular memory location, I am storing some value, let us say 10. Okay, when I say num is equal to 10, that means the value of this particular memory location, I have given it as 10. So here 10 is the value and this is the variable name. So in Python, you have to remember that we can simply create a variable by just assigning the value to it. If you observe here, I can simply say like a is equal to 10, b is equal to r. Okay, I don't need to say like in other languages int a is equal to 10 to represent a as an integer value, or char b is equal to r to represent it as a character value. So I'll be just showing you the little bit snippets of programs also after this. So variable assignment, you can change the value of the variable by assigning a new value of a different data type. See how flexible Python is. So here I have, suppose for example here, I'm just having a is equal to 10 here. Later down, you all know that this is going to be, it's a value, whole number. Okay. Now suddenly I'm going to say hi, a is equal to my name. Okay, Rupa here. Now what happens? This is a string. String is a group of characters which are enclosed in double quotes. Okay, so I can just put the string inside this for same variable a. So this is possible in Python. It is not going to show any error for me. Okay, so variables can have it can be a local variable or a global variable. Scope means when we declare a variable within a function or inside a function or outside a function, how we can access those variables. That is the scope of a variable. So a local variable, when it's within a function, you cannot use that variable outside the function. Whereas a global variable can be defined outside the function. We'll look at this in the later units. In Python, everything is treated as an object. Okay, Python is considered as an object-oriented programming language. So everything is treated as an object. What is an object? Object is an entity which has a specific characteristic and behavior. Characteristic and behavior. Characteristic is nothing but the properties of that particular object, and behavior is the way that object behaves. Okay, the way that what you can do with that object actually. That is behavior. It's a very vast topic, object-oriented programming, but you should understand Python, though it is treated as object-oriented programming, some of the objects will have only the methods. Okay, behavior is nothing but it is represented as your methods, and some of the objects may have only the characteristics. Okay, so it is not like purely like, you know, the objects may have both the members and the methods. Okay, the data members or the data variables are known as the characteristics. That is, it can be assigned to some variable or and can be passed to a function as an argument. Every object in Python is assigned with a unique identity ID, which remains the same for the lifetime of the object. This ID is similar to the memory address of the object. So what exactly happens is, so I was talking about the variables being declared, isn't it? So in your memory cell, for example, your num is okay, right here. Okay. We have these memory cells. Okay, so here, if you can see this, suppose this is where num is getting, I'm calling a particular variable as num, and the address associated with this num, let us say it is 2000. Okay, and the value of this num is what I've given the value as 10. So this is where num is associated. So here num is equal to 10, and when I put this ID num here, I'll get this value 2000. Okay, ID is a particular value which that particular variable is associated with. Okay, it's like a memory address. In the other languages, they are known as the memory address. Now num1, I am giving num1 as 20. Okay, so I'm having one more variable which is called as num1 and its value is 20. Now if I say ID of num1, yes, num1 may be associated with some other memory address. Let us say it is associated with, say, let us 2020. Okay, and now if you observe, now I say num2 is equal to 20 minus 10. What is 20 minus 10? 10 again. So here num is also 10. Okay, num is also 10 and num2 is also 10, isn't it? So both this is now associated with the same address. Okay, both of it is going to have the same address. So I'll just show it to you in the Python editor. Okay, I'll just show you this ID problem in the Python editor so it becomes more clearer for you. So we'll just look at that. Okay, I'll just, here I've opened the VS editor now. So I'll just open the new file here. I'll go to the Python file here. I'll create a new file. So here, as I was telling you, we can have the variables. So I just declare one variable now. Okay, I can show you the same problem. Num is equal to 10. Okay, and then I can put ID of num. Okay, so here print ID of num. Okay, so here I'm just running this program. Okay, just run the program. The dedicated terminal. It's asking me to save the file. So I will give it as var1.py. Okay, saved it as a Python program. Now can you see? This is the ID. Okay. So you can use ctrl plus to make the editor, the font bigger. So this is clearer. So can you see this? This is the ID that I have got. Okay. Now let me put this. Okay. Let me now put this. Here I'll just put num1 is equal to 20 minus 10. Okay. 20 minus 10. And then I just say print, okay, ID, and then I put num1. Okay. So I should expect a different number here. Yes. So I'm again, if you observe, you just observe here. When this program is run, num1, what is the value of num1 now? It is 20 minus 10. It is going to print 10 again, isn't it? I'll put one more print statement here. Print num1. Okay. And here I'll put again print num. So what exactly happens here? We will run this program here. Go here and say run Python in a dedicated terminal. So you can just see, I'll just zoom it. So can you see here? So first what is this? First it is printing num, which is 10. What's the ID of num? 140734619444296. The second time I am actually printing num1, okay, and print num1 is also what it is doing, print ID num1, it is also printing the same thing. So this is what I was telling you, that the variables is giving the reference to the same point if the value is going to be same. So here what actually happens is, we are actually so it only just tries to store it in a different location. The variable is, once you create a variable, it is immutable. Immutable means it is not able to change. So in the same memory location, it is not able to change. Okay, so it is created in a different place. Okay, num is created in a different place. Num2 is also created in a different place. Okay, num is here. All this is pointing to the same memory location. So num points to this memory location. Let us say whatever value we got, 2000, and num2 is also pointing to the same memory location. Okay, so this is the ID, which is the unique ID, but yes, here it is just the value is getting changed. Okay, so as I was telling you about these variables, let us continue. Comments in Python. Comments are used to understand the working of the source code. In Python, a comment starts with a hash sign. So we need to remember this. So when I use a hash sign, for example, my first program, this will not be displayed on the screen. Okay, this will not be displayed on the screen. And then we will also look into the data types. Okay, next slide, I'll talk about the data types. Before that, I would like to actually show you the same some few simple programs here. So here, if you see here in this, okay, as I was telling you, these variables you don't need to actually, declare any type here. You can just say num is equal to 10, and then you say print num. So what happens when I run this? It is just going to print that particular value. Okay, so let's say, see here. So it's just say print num. It is printing the value here. Okay, so I say print 100, and then again I say run. So you can say that it is printed 100, isn't it? It is printed 100 here. The shell can be seen more clear. Yes, it's printed 100 here. Now let me say the same num. Okay, I want to just go and make a change here. I say now num is equal to, I just give a string num. Okay, now again when I print this particular string, I say that print num. Okay, so here I go here and say, see, it's not showing me any errors. Okay, so first it is printing 100, next it is printing 100. So it's not saying, okay, this is a different data type, right? So this is possible in Python. Okay, so there is no way we are declaring what type it is, but you want to know what is the data type it is. Okay, you don't know what is the data type, so you can always type like this. You can just say print, okay, print, and you want to know the type of this particular variable. Okay, now I say print type num. Okay, so the last value of num was a string, so it says class str. Okay, now if I put the same value here, okay, if I now say here print type num, okay, and now I run this particular program. Okay, so it says class int, because 100 is integer, a whole number, whereas hello is a group of characters which is known as a string. So this is how it works. Okay, it's very easy, very simple. You can write very nice programs using Python. It's an easy language to learn. But yes, sometimes here and there, if you're knowing other languages which are very strongly typed, this you may find it a little confusing. Okay, so this is what it says. It's class str. This is class int. Okay. Now let us look at the keywords. Okay, keywords. So sorry, let us look at the. We will go back to our PPT and start learning about the data types. So let us continue with data types. So here if you see this particular table, the data types are broadly classified as numeric, dictionary, boolean, set, none, sequence type. So numeric data type is of three types. One is your integer data type. So integer data type, next is float, then you have complex numbers. And in sequence type, we have strings, list, and tuple. So we'll go through each one by one. And again, these data types can be immutable or mutable. Immutable data types are integer, float, boolean, complex, string, tuples, and sets. And mutable data types are list and dictionary. What do you mean by immutable data types? Immutable data types means the data types values, once they are declared, the values can be changed, but their memory location remains unchanged. Whereas in mutable data types, in that particular memory location, like variables I told you, they are memory locations. So you can change the values in the particular location itself. So lists and dictionaries, the values can be changed in the memory locations itself. So when it is changeable, it is known as mutable, and it is unchangeable, it is known as immutable. Let us look at the first data type, the numeric data type. Numeric data type is made of three parts, that is, there are three types. One is int, float, and complex. Int represents integers or whole numbers. In a previous example on the Python editor, I showed you this. Float represents numbers with decimals. So when you have numbers with decimals, those data types are known as float, and they are also known as real in many other languages. And you also have another data type called as complex in Python, okay, which represents values like this. Another new data type that you have here is called as a sequence. Okay, strings are very common in many languages. A sequence is an ordered collection of items where each item is indexed by an integer. So in other languages like C or C++ or Java, many would have known that strings is nothing but a group of characters which are enclosed in the double quotes. Okay, that's how we represent. Char is represented as single quotes, and string is represented in double quotes. But in Python, you can represent the string either in single quotes or in double quotes. You can see here, this can be, both are valid, both are correct way of representing a string. So it is not going to show us any error when we do this. So that's why, this flexibility of Python is seen. Sequence, there are three sequence data types. Okay, so the second one we talk about is list. List, you might have, when you're going to a market, you may prepare a list, isn't it? Like this, you make a list where you want to buy some stationeries. Let us say you say pen, pencil, eraser. You make a list. So here also you can have a sequence of items in a list. So whenever we use a list, we need to remember that we need to use a square bracket. Okay, list, you have to use a square bracket. Now this is important because we don't write the data type here. We don't say list and some, list A is equal to this, nothing. We don't know that it is a list. If you have to know that this particular variable is a list, it has to be enclosed in a square bracket. Then you know, okay, this is a list in Python. The third type of sequence is called tuple. Okay, tuple, T-U-P-L-E. Okay, it's not tuple, it is tuple. Tuple is a sequence of items separated by commas, and items are enclosed in parentheses. So if you observe here, the difference between a list and a tuple is a list is enclosed in a square bracket. Okay, this is a list, whereas if it is enclosed in a parenthesis, then it is a tuple. So if you can see that this is just a collection of items. Okay, one after another, these elements are placed in a tuple. Then you may want to know what is the difference between them. The main difference is lists are mutable and tuples are immutable. That means what? Once these are created, you cannot change the tuple. Okay, you cannot make any changes to the tuple. Look at this few things in this one in the editor. It just shows few examples. The next data type that we have is known as a set. Okay, set, many of you would have learned in maths. A set is a collection of items. Okay, so here also it's an unordered collection of unique elements. And how do you declare a set? See, set can be declared in two ways. One, you can put these curly braces or these flower brackets and declare a set, or you can use a function here. Okay, it's a constructor. A set constructor is used. A set cannot have duplicate entries. That means you cannot put the same entries inside the set, and it is immutable. Immutable is once it's created, it cannot be changed. Okay, these are the features of the set. We can do operations on the set like add, remove, union, intersection, difference, etc. Just like in maths you might have learned union, intersection. Here also you have these words through which you can actually operate this on the sets. So sets are the first example here. We are showing how to create a set using a braces like this. So you just write any name for the set, like let us say set 2 I am writing. I have to put these braces like this, and then I can put the set elements like this. And the set elements, if you observe, they are all of different data types. Even this is valid. Okay, and then I just need to say print set 1, and you will be able to get the value. It is perfectly correct. Okay, the sets can be used using the set constructor also. So since it's a constructor, inside this is the way you declare a set. Adding elements to the set. So set, if you want to add more elements to the set, okay, you will have to say set 1, okay, is equal to 1, 2 and 3, like this. Okay, if you want to add more element, you will say set 1 dot add, and then you will add 4. Now I'll just give you a question here. Can I add more elements with this function? Add is a function here. Okay, it's a method here. So can I add more elements? Okay, I'll tell you towards the end of the slides. Okay, similarly, if you want to remove some element from the set, you can remove the element. Let us look at the operations on sets. So there are 3 operations: union, intersection and difference. Just like in maths, union is just taking all the elements in both the sets. So here, for example, you have set 1, okay, you have set 1 with all these elements 1, 2 and 3, and you have set 2 is equal to 4, 5 and 6. Okay, 3, 4, 5, 6. So when you say set 1, okay, when you say set 1 dot union, okay, set 2. Okay, let us put it in another, this one, set 3. So set 1 dot union set 2, what it will return? All the elements here. Okay, it will not take the duplicated elements. So it will take 1, 2, 3, 4, 5 and 6. So all this will be printed. When you say intersection, what happens? Which is common here? 3. So when you say instead of union, if you're going to say intersection, okay, if you write here set 1 dot intersection set 2, then you will get the value 3. Difference is, if I'm going to write the difference like this, set 1 minus set 2. Okay, so here it is going to, since set 1 is written first, it is going to take this, it's not going to take the common element, it will take the other elements which is there, and it will return 1 and 2. So this is all possible with sets. Okay, Boolean data type, the next data type that you have in Python is called Boolean data type. So it can take true or false, and this is mainly used in the while loops, okay, while true, okay, and in the if statements for the logical decisions to be made. The Boolean data type is used. And then you have another data type called none. None is something like your null value. Suppose you don't want to put any value, okay, sometimes there might be absence of value in a situation. You can declare a is equal to none, okay. So more than saying it's a data type, you can say that it is kind of a reserved word, a keyword, okay. But some books, they say that it's a data type because it is actually, when you type the written data type, it gives the class name as none data type, okay. But you cannot create any objects of this data type. So when you don't want to give, like for example, I want to give a is equal to 10, but sometimes I don't want to give any value at that particular time, I can give it as none. So like a null value it is, okay. Capital N you have to put. Okay, and this is also very interesting. Then you have something called as a dictionary data type. Now, a dictionary is, a dictionary is generally used for what? When you want to relate something, like, want to look up at something related with two values, then you have a dictionary, isn't it? So, a dictionary data type is a mutable data type. That means whatever value is stored there in the actual location, that can be changed, okay? So that is what you mean by saying mutable data type. So what is, there is a term associated here known as mapping. So mapping is an unordered data type in Python. So one of the mapping data types, there is only one mapping data type at present in Python. It is called as the dictionary data type. So this holds a key value pair. Key value pair means, see for example, in your mobile phone, this is a uh, very suitable example. In your mobile phone, for example, you have a name and then a number, isn't it? So this name is associated with the number. Similarly, when you're writing a dictionary data type, you are going to write it in flower brackets like this, okay? And you are going to associate one string, generally it is a string, with some value, okay? So this is known as a key value pair. For example, here you have this Amy, okay, and then you put a colon, okay, you separate these value and the pair as 67. So this may be the marks that she has obtained, okay. If you assume that this is the marks, Amy 67, or the age, anything it can be, okay. Here I have taken the example of marks. And then if you want to retrieve this particular data in this key order pair, you can say Rita underscore score. I'm just giving another variable, it is equal to marks Rita. So I will get the value here as 88, okay. So this is data type known as dictionary data type. So all this can be, actually we can also just do it in the Python interpreter and check on all these results. I would want you to, I would want to show it on the interpreter also, but I will be doing it in my next video. Some examples, program examples we can take, and we can do on all this what we have learned, the basics today. Hope so you have understood all these data types. And in my next videos, the upcoming videos, we will do the examples, and also we can do the next part of Python, that is the operators and expressions. Thank you for watching. Have a nice day.